Hi everyone, my name is Ravi Prakash and welcome to the first class of clocks. So we'll look at all the basic concepts of clocks and we'll do some good advanced questions also in clocks. Okay. So see here, suppose the first thing is, if I draw a clock here, like 12, 6, 3 and 9. So from the concept of circular tracks, we know that whenever two people are running in the same direction, and their speed ratio is m/n. Whenever two people are running in same direction and their speed ratio is m/n, they will meet at m-n distinct points on the clock or on the track points, and those points will be equidistant. Right. So this we know by circular tracks, right? So whenever two people are running in same direction in the ratio of speed ratio of m/n, where m/n is in lowest form, right? Lowest form. After cancelling, lowest form. Then they'll meet at m-n distinct points on the clock, and those points will be equidistant on this track. Sorry, not clock, track. Okay. They'll meet at m-n distinct points on the track, circular track, and those points will be equidistant. So same way in clock, what happens? We have two people running also here, hour hand and minute hand. Okay, so hour hand and minute hand are running in clock, and their speed ratio here is, here is 1:12. 1:12, right? So speed of hour hand and minute hand in a clock is in the ratio 1:12, right? Why so? Because suppose hour hand and minute hand are at this point now at exactly at 12. So in the time, let's say clock is divided into 12 parts, right? 1, 2, 3, like this clock is divided into 12 parts. So when this hour hand covers one part of clock, in that time this minute hand comes from here to here, covering 12 parts of clock. So when hour hand moves one part, minute hand moves 12 part. That means their speed ratio is what? 1:12. Okay. So that means if their speed ratio is 1:12 and they're running in same direction, obviously hour hand and minute hand are moving in same direction, right? Same direction only, right? It's only in horror movies that they move in opposite direction. Okay. Normally they'll move in same direction. Okay. So hour hand, minute hand speed ratio is 1:12. That means they'll meet at 11 distinct points on the clock. Right? So ratio here is m/n, and they will meet at 11 distinct points on the clock, because m-n distinct points, 12 minus 1, 11 distinct points, right? That basically means that if I make a clock here, so they will be meeting at 11 equidistant points on the clock. So let's say first time they are at 11 together. Okay, at 11 they are together. Then after what time again they will meet together, right? Roughly, what you can say roughly. So they will meet at roughly 1:05, hour and minute hand almost there. At 2:10, hour and minute hand almost there, right? So what is that exact timing, right? So basically this is 11 distinct points, 1, 2, could be 3, right? Then 4, like that. So 11 distinct points that all are equidistant. The gap is equal. This gap is equal, right? This gap is equal gap, because they are equidistant points, so gap is equal. Okay. That basically means that, so in full 12 hours, right? For whole 12 hours, we take 11 distinct points here. 11 distinct points. So that means 11 distinct points, that means there are 11 gaps also here, right? Each gap is equal, there are 11, because it's a circular track, no? So number of points is equal to number of gaps also, right? If it was linear, then 11 points you draw, you'll get 12 gaps, right? But here it is circular, so 11 points is 11 gap, right? So 11 equal gaps consists of 12 hours. I can think like that. So 11 equal gaps consist of 12 hours. So what is the interval of one gap? So interval of one gap is equal to 12 by 11 hours. 12 by 11 hours is equal to 12 by 11 into 60 minutes. This is equal to 720 by 11 minutes, right? So therefore, now 720 by 11 if you solve, you get 65, sorry, you get 65 5 by 11. 65 5 by 11 minutes. This is a very important data, right? What is data is? This data is that after every 65 5 by 11 minutes on a clock, 11 minutes in a clock, the hour hand and minute hand will coincide with each other, will meet, or I can say coincide with each other. Right. So what's the logic behind it, right? So logic behind it is again same thing. When they are moving in the ratio of 1:12, they'll meet at 11 distinct points on the clock. Those 11 distinct points are equidistant, but that means their gap is equal. What is the interval of one gap? So total 11 gap is consisting of 12 hours. So what is the gap? What is the value of one gap? 12 by 11 hours, that is 65 5 by 11 minutes. That means this gap also 65 5 by 11 minutes. This gap also 65 5 by 11. So all gaps equal to 65 5 by 11, right? So this is a very important data in clock. Okay. Then we'll see what is the angle swapped by hour hand, minute hand, right? What is the angle swapped? So hour hand and minute hand. Okay. So for hour hand, what happens? We'll first look at the speed ratio, right? What is the speed, and then look at the angle also. So what is the speed of hour hand? So in a clock, when hour hand will move from 12 to 12, hour hand will cover 12 parts of clock and total 360 degree, right? So 360 degree it covers in 12 hours, hour hand. Okay, that means what is the speed here? Its speed is 30 degree per hour. So speed of hour hand is in terms of hour is 30 degree per hour. In 1 hour it moves 30 degree, in 2 hours 60 degree, like that. Okay. Then if I say in minutes, so okay, then our 30 degree, that is per 60 minutes. So in every 60 minutes 30 degree, that means it should be half degree per minute. It should be half degree per minute. This is the speed of hour hand here, right? So hour hand is moving at the rate of half degree per minute, or 30 degree per hour. By what rate minute hand is moving? Minute hand. If you see minute hand in the same clock, so minute hand moves like this, right? Suppose there's a minute hand at 12 right now. Okay. So minute hand in 60 minutes covers full 360 degree, right? So minute hand in 60 minutes reaches from 12 to 12. That is 1 hour. It reaches from 12 to 12. So minute hand covers full 360 degree in 60 minutes. So 360 degree in 60 minutes. That means its value is what? 6 degree per minute. So speed of minute hand is what? 6 degree per minute. Speed of hour hand is what? Half degree per minute. Okay. And what is the relative speed? Relative speed of hour hand and minute hand is what? Since both are moving in same direction, so difference of speed, that is 6 minus half, that is 5.5 degree per minute. So we'll use all these concepts while solving the questions. We'll use all these concepts while solving the questions. Okay. Now, okay, here's a question here. So hour hand and minute hand of an imaginary clock coincides after every 64 minutes. How much time the clock will gain or lose in a day, right? So what we know now, as in any normal clock, right? As in any normal clock, hour hand and minute hand coincides after every 65 by 11 minutes. This happens in any normal clock, right? We just studied. So, but in this clock, they're coinciding after 64 minutes. So those two hands are to meet after traveling for 65 plus minutes, right? And in this case, they're meeting at only 64 minutes. That means hands are moving fast, right? So if hands are moving fast, that means the clock is gaining time, not losing time. If hands are moving fast, that means clock is gaining time, right? So how much time clock has gained? So I can say that after traveling for 64 minutes, how much time they have gained? They have gained the difference. What is the difference here? From 65 5 by 11, that difference is of 5 by 11 minutes. So after traveling for 64 minutes, they have gained 5 by 11 minutes, right? That is equal to 16 by 11 minutes. This is a funda, right? So after traveling for 64 minutes, how much time they have gained? So they were supposed to meet at 65 5 by 11 minutes, right? But in this clock, they are meeting at only after 64 minutes. That means the clock has gained 16 by 11 minutes after moving 64 minutes. So that's not simple, right? So in 64 minutes, they are gaining 16 by 11 minutes. They are gaining. So by unitary method, in 1 minute, they'll gain how much? 16 by 11 into 64 minutes they will gain, right? This is a basic thing here. This is an important thing. Calculate for 1 minute. Rest the question can be anything, right? How much time it lose in a day, in an hour, in 12 hours, in 8 hours, right? That's simple thing. But the main thing is to calculate till this part. So in 1 minute, the clock will lose how much? 16 by 11 into, clock will gain how much? 16 by 11 into 64 minutes. This much time the clock will gain. Okay. So now our question is, in a day how much it will lose? Gain in a day how much? So in a day means 24 hours. So in 1 minute how much? In 1 minute this much. So in 60 minutes it should be 16 by 11 into 64 into 60. So therefore in a day, in 1 day, that means in 24 hours, I'll multiply by 24. 16 by 11 into 64 into 60 into 24. This should be the answer, right? If you solve it, you'll get the value as 360 by 11. That is equal to 32.8 by 11 minutes. So my answer for this question will be 32.8 by 11 minutes. This much time the clock will gain in a day. This much time the clock will gain in a day if the hour hand and minute hand coincides after 64 minutes. Is clear, right? Okay. So now what we'll do, we'll try to find the angle between hour hand and minute hand in a clock, right? So what is important here is, see, once you're trying to find the angle between hour and minute hand, so in a general clock there's a normal formula, right? We'll derive that formula, can remember it. Okay, but the thing is that derivation is very important, because in exams I don't expect much questions on normal clock, right? So what the question they're giving, there's a different clock, like there are 24 minutes on the clock instead of 12, or there's a semicircle kind of clock, right? So in those questions, that if you have to find the angle funda, right, then you should know this, how we have derived this, so that derivation will be applicable to that the different clocks also, right? But that formula will not be applicable, because this formula is only for our clock, this general clock, when there are 12 units on a clock. Otherwise this formula is never applicable. So that's, I'll derive this formula. That's very important. Derivation is very important for the other questions point of view, and this for simply you can remember the formula for normal clocks, right? So let's derive it now. So find the angle between hour hand and minute hand at a certain time wave. So let's say this is 12, 9, 6, 3. Let's say the time is now, for example, take any time. Let's say time is now 7:30 kind of. Okay. So minute hand is here at 6, hour hand is at 7. So we're trying to derive this angle here, this angle, this theta. I'm trying to derive, right? always my base is at 12. So initially let's assume that this 12, the hour hand, minute hand both are at 12 only, right? So initially hour hand and minute hand both are at 12, and after that till 7:30. So my logic will be how to find this theta. This theta will find by this total angle traveled by hour hand. Total angle traveled by hour hand minus the angle traveled by minute hand. Correct. So my logic will be here. The total angle traveled by hour hand from 12. Okay. The total angle traveled by hour hand till 12 minus the angle traveled by minute hand. This will give me this theta. This is my logic here. Okay. So how to approach? It's quite simple. So we just write how to calculate theta in any clock, right? In any clock, theta is equal to angle traveled by hour hand minus angle traveled by minute hand. So obviously you can say that when minute hand is above minute hand is above hour hand, in that case angle traveled by minute hand, suppose minute hand was here. In this case angle traveled by minute hand minus angle traveled by hour hand, right? Just reverse it. So it's okay. You don't need to take that into consideration here, right? So angle traveled by hour hand minus angle traveled by minute hand. What is angle traveled by hour hand here? So we know that hour hand travels 30 degree per hour. We have done this. So hour hand travels 30 degree per hour. So till 7. So let's say time is 7:30 now. So till 7, the hour hand travels 30 degree for 7 hours each hour, right? 30 degree for each hour. So for 7 hours, 30 into 7. So right now hour hand is here, exactly at 7, right? But it has to go at 7:30. That means for extra 30 minutes, the hour hand will travel how much? What is the angle traveled? So hour hand travels at half degree per minute. So in 30 minutes, hour hand moves at half degree into 30 minutes, right? 7 is hour, 30 is minutes, right? And then we'll generalize for h hours and m minute. Okay, this is for 7:30. So this total angle traveled by hour hand, 30 degree in for 7 hours from here to here, 30 degree for 7 hours, and plus for this extra 30 minutes, that is half degree per minute, that is half into 30. Now minus angle traveled by minute hand. So what minute hand has traveled here? So minute hand has traveled from 12 to 6, that is for 30 minutes. So minute hand travels at 6 degree per minute. So in 30 minutes, minute hand will travel 6 degree into 30. Again, that's per minute, right? This will give me the answer. To 210 plus 15, 225 minus 180, my answer will be 45 degree. Should be my answer. 45 degree. Correct? So now generalize this for h hours and m minutes. So 30 into 7 is h here, hour, plus half into m, 30 is minutes here, minus 6 again is degree and 30 is minutes, that is 6m. So what I'm getting here is at hm, that means at h hours and m minutes, theta is equal to 30h minus 11 by 2m. This is the formula I got for general clock, right? But this derivation is very important for any other clock if it comes in the question. Like the clock is divided into 24 parts or 36 parts, or clock is in shape of a quarter circle or semicircle, like that. This will be very useful, that derivation. You can straight away do like that. So theta is equal to 30h minus ln by 2m when h is above m. Minute hand is at 6, h is here, hour hand is here, right? If minute hand was above hour hand, in that case it should be what? Just reverse it. 11 by 2m minus 30h. 11 by 2m minus 30h, right? This is the formula in this case. Okay. So just for example, okay, suppose the time is now 10:45. So what is the theta at 10:45? So theta, that means what is the angle between hour hand and minute hand at 10:45? So hour hand is basically h is 10 and m is 45. So I can simply say that hour hand is above minute hand, right? Because hour hand is 10 plus and minute hand is at 9. Because what is the time now? This time like this, right? You can simply imagine hour hand is here and minute hand is here, right? At 10:45. That means hour hand is above minute hand. So use the formula 30h, that means hour hand minus minute hand. So use the formula 30h minus, or I can put mod also, but it's fine. It's a 1 second process, right? Not even 1 second. If h is above hour hand, use h minus m. If m is above hour hand, use m minus h. That's same thing. So h is above minute hand, hour hand is above minute hand, use h minus m. H you replace by 10, m you replace by 45. So you get 300 minus 22.5 into 11. So 300 minus 22.5 into 11 is 247.5. That is equal to 52.5 degrees. This is the answer. If the question was, what is the timing at 5:48? So for 5:48 is a time, 5:48 p.m. let's say. What is the value of theta here? So at 5:48, this is a situation. Hour hand is here and minute hand is here. So minute hand is above hour hand now, with reference from 12 always, right? So hour hand has traveled less distance, minute hand has traveled more different distance. In that case, it should be minute hand minus hour hand. That means 11 by 2m minus 30h. That is 11 by 2 into 48 minus 30 into 5. That is equal to 114 degree. I think 24 into 11, 264 minus 140, 150, 114 degree. That is the answer. Right, this is the most basic part of clock, right? So we should know all this to solve tougher questions of clock. So in the next videos, we'll see how to solve tougher questions of clock. Okay, including this, using these concepts, we'll see different kinds of clock also. When clock becomes semicircle or quarter circle, or different kind of how to solve it. Okay. Thanks for watching.